Good. All right. So, welcome everyone. Hope everyone had a good lunch break. I'm glad to get the after lunch so that people can nod off and I don't have to worry about being really good up here. So I'm presenting DADSEC 102. DADSEC 101 was a small presentation I did at A2I ASM in September. That's a small conference between, it's an Ann Arbor and Ypsilanti area conference that's held annually. There should be details about this year's coming out fairly soon, I believe. So first, a little bit about me. My name is Rich Cassara. I go by @RJCassara on Twitter and elsewhere online. My background is mostly in systems administration and DevOps stuff. I live in Ann Arbor, and to prove that I have the qualifications to talk about DADSEC, I am a father to 3 children, and there's a picture that's a little outdated because it's from last summer, but that's us. So just quickly off the bat, what do I mean by DADSEC? It's kind of it's built off of the idea of building my network for security for my family at my home. So it's like the kind of basic security that you need to get out of the way that you can afford to do just by yourself. So this is also applicable to a lot of small businesses. If your IT department, you don't have a dedicated security department, you just have IT and there's like 1 or 2 guys that's doing all your networking, all your systems. You know, what's the kind of security, what's the best bang for your buck that you can get with limited money, limited resources, limited staff? And to get off the bat, even though I've named it DADSEC, that is in no means that it has to be the father in the family that does this. I know tons of amazing women in InfoSec who would be amazing at doing this as well. So the reason it's dad is that I'm using dad as a prefix. The way that we have dad jokes. And for a brief period of time, there was an internet phenomenon of dad bod. Thankfully, that doesn't seem to be going around so much anymore. So DADSEC is kind of in the same vein as those things, in that dad as a prefix means, it's all right, it does enough. And that's what we need for security for our home networks. You need to do enough. You don't need to go all out. So in thinking about this, one thing I wanted to bring in, this is a common thing in project management. I'm sure many of you have seen it's called the iron triangle, and it's about the cost, quality, and time. And you often see it like you can only pick 2. And I don't like that idea exactly, because I don't, which I'll get into in a minute. This is another thing. This is how it's often presented. And there's a few problems I have with the way that this is presented. First of all, I don't think that the labels should be on the sides of the triangle. They should be at the angles. Because the thing about the angles of a triangle is that no matter what you do to a triangle, it's always going to add up to 180 degrees. And that's the way that these things are all constrained. You pull on, you shrink one, then the others are going to have to increase in some way. So your cost, time, and quality of your security or any project that you're working on, they're all intertwined rather. And the other thing I don't like is I don't like the term quality on there. The reason for that is because cost and time are both metrics that you ideally want to be as small as possible. But quality is the opposite of that. You'd rather that be really big. So if you think of it, if you're thinking of it as a triangle and you're like, okay, we're going to shrink our cost and shrink our time, our triangle ends up looking like this. So it's like, oh, we've got great quality, low cost, low time. That's amazing. That's not going to happen. So we really need the opposite of quality. And I was trying to come up with a good word for that, and I couldn't really think of one in English. Which might be why it's always labeled as quality. But in the spirit of DADSEC and doing things that are just good enough, I thought suckiness was a good enough word to put in there that accurately captures what we're talking about. So we can think about how we can modify this triangle for our security purposes. The other problem, so going back to the previous slide where I said, there's often this idea of you can only pick 2. The other thing, you look at this is an equilateral triangle. You're not picking two, you've actually just gotten a balance between all of them. And that's something that we can kind of strive for in the ideas of DADSEC, is that we're gonna spend a little bit of money, spend a little bit of our time, and get a pretty good outcome. So how do we go about starting our DADSEC process? What I've come up with is that it is a 3-step process. The first step is going to be threat modeling. So the threat model for DADSEC is mostly based off of the seminal article by James Mickens, This World of Ours. If you have not read it, I highly recommend it. And if you have read it, I recommend rereading it because it's amazing. In this article, he goes through the Mossad, not Mossad threat model, in which you have these types of threats, which are not Mossad. And the solutions to those threats are pretty easy to implement and reasonable. And then you have the Mossad threat model, and then you have a problem. And in DADSEC, we are not worried about the Mossad. And it doesn't have to be Mossad, it could be NSA, it could be Fancy Bear, any large state-sponsored organization with limitless resources to attack you. They're not our threat when we're protecting our home networks or small businesses, unless some extenuating circumstances exist. That also ties into, this was some drama on Twitter a few weeks ago, cyber hygiene. This was kicked off by this article. And so there was an NSA official who was quoted as saying, basic cyber hygiene could prevent a majority of these cases, in which the Equifax struts vulnerability was, a lot of data breaches were still achieved through those. And so there were people who said, well, that's ridiculous to say that because what about APTs? And they're not wrong that if you do have a persistent attacker going after your network, basic cyber hygiene isn't enough. But in DADSEC, it is enough. You keep your systems up to date on patches, you don't click weird email links, and you're mostly fine from these threats. But these are only half of your threats because you have 2 threat interfaces. What we've talked about so far are just the outside threats. You also have your inside threats that you need to model for. And that was, actually that was briefly talked about in one of the earlier talks today. I also want to point out this little box here is extremely important. In DADSEC, you need a perimeter device like this. I'll talk about a bit more down the line, but it's at small businesses, I generally hope have some kind of a firewall, but in a lot of homes, you may not be running your own firewall. I highly recommend it it does a lot of good for you, and it doesn't have to cost very much. So talking about our internal threats, these are highly dependent on your individual environment. Everybody's got a different threat that they're worried about depending on what you do, the kind of personnel or the kind of people in your family that are using the technology. You need to be aware of what your real threats are going to be from the inside. Now, in a business, you may be worried about your employees stealing company data, selling it to competitors in exchange for a cushy job or cash. That's something that you would need to worry about in your threat model if you're running a small business. That's not generally a problem at homes, and you're not usually worried about your children leaving your family for a competing family. Although if your child is considering that, you might be willing to let that one go anyway. But then when it comes to your internal threats at home, it could be something that's very different. Like a business does not care if their address is listed because they need people to find them. But if you've got small children, you don't want them passing out your address to strangers they are finding on the internet. So those are the threats, kinds of differences in your internal threats. So once we've done this threat modeling, it doesn't have to be an official document that you've gone through. It just can be some mental exercises going through, really understanding the layout of your environment and what you need to worry about happening Then you can move on to the meat of DADSEC, which is monitoring and alerting based off that threat model. So when you're going to monitor things that are happening in your environment, what are you going to monitor? Ideally, you want to monitor everything. And in a large corporation with a dedicated security team and staff, you can monitor pretty much everything. But that is not at all realistic if you're just doing this by yourself at home. You got to pick and choose what you monitor. So one thing you can monitor is what's going on individual systems. Now this is a small program I wrote because I was thinking about things to monitor and trying to figure out ways to do that. This is I named it Hops to make it family friendly. It's a cop for your systems, kind of. And it runs, you can set it to run periodically, and it grabs the processes and active network connections on a system, and then it packages those up into a JSON document, sends it to a server component, which loads it into a MongoDB database. And then you can search that and get a snapshot of what's happening in your network at any given time. And I thought, oh, that's pretty neat. It's not very good because I didn't put a lot of effort into it, because DADSEC, we're not putting a lot of effort into these things. But just like anything, if you have a good idea, a program that seems like useful and interesting, somebody else probably had that idea already and has done it better than you could with more resources. And that's called OS Query, which does what I did, but way better. This is an open source project primarily run by people at Facebook. And it basically turns an entire computer into a searchable database of information. So for example, I'm not sure if you can read that because it's kind of small, but this is it's a little SQL query. You run it directly when you have OS Query installed on a system. You can run this, and this does, I'm selecting the name, process ID, and how many bytes are written from the process table, because it makes tables based on the different things that you're running on your system. You can also query network connections. You can query a whole bunch of different things, connected USB devices. So then I grab this, I sort it, and then you get an output in a nice little table, and you can see which processes are taking up using the most disk space at a given time with this query. It also can be run as a daemon and then have that information sent up to a server. And you can log all this information and get a lot of good stuff out of it. So speaking of logs, logs are the lifeblood of monitoring, and everybody loves logs. You can get so much out of them, but there is a really large, the signal to noise ratio is really bad. And that's something you need to fix. So the way I was thinking about logs, you'll probably see where I'm going with this in a minute. If you think of an individual log file as a robot lion, it's really powerful, it's useful, it can do some great things, and you can have a bunch of them and they're all great. But if you really want to get a lot of power out of your logs, you need to find a way to combine them. And that's where log aggregators come in. So there's a number of open source options for log aggregation, and they're open source and non-open source. I'm going to just list a couple. There's the Elk stack is used by a lot of people, works very well. Graylog, I've heard great things about. I have not had a lot of chance to play with it myself, so I can't speak to it personally, but it's very highly rated. What I am going to talk about is Splunk. Splunk is one that is not open source, it's proprietary, and if you ever talk to someone about Splunk, one of the first things they'll say is, oh, Splunk's expensive. And they're not wrong. The price for it can really add up with the amount of data, depending on how much data you're sending to it. However, if you're working on a project just for your home network, Splunk has a developer license. You just have to give them your email and say, I'm interested in developing on Splunk, and you get a 10 gig allowance. That license is good for 6 months, and I'm not certain, but I think it can be renewed if you need to. So this is really good for playing around with getting your data. And like I said, Splunk, it's one that I'm familiar with because I do use it at work, and it is something that it's really easy to set up. So what I'm going to go through getting some logs together and analyzing them with Splunk is DNS logging. DNS logging is a really powerful thing to do in an environment because you can find out what's your network talking to. Really want to find out. You can find out just a lot of stuff from that. So this goes back to this little box that I mentioned earlier, where you really need to have a perimeter device, a firewall on your home network. I highly recommend using pfSense, which I'm going to show here. pfSense is open source. It's based on FreeBSD, and it is primarily a firewall, but it has a package manager that you can add all kinds of capabilities into it. It all gets managed through web interface, and it's done amazingly well. It rivals, more than rivals, it's better than a lot of paid firewall software, and it's completely open source. I really like working with it. So as I was saying, within pfSense, this is a little screenshot from the web interface. In here, I've added from the package manager, I put Suricata as the package linked into it. Suricata is an open source IDS that can grab all the packets that are going through and get information from those. By default, it does not log DNS, but it's very easy to go in. These are the settings where I've enabled DNS log. So now the Suricata on my pfSense box is capturing all the DNS logs that are coming from on the LAN interface. You can separately do it on the WAN interface as well, but I don't see the need to do that for my purposes. Again, DADSEC, we're just doing enough to get what we need without going over the top because we have limited time, limited resources. So once we've gotten, now that we've got the DNS logs enabled, then you can go in and view those logs directly in the pfSense interface. This is showing the DNS logs. And as I said before, with logs, there's a lot of noise, very little signal. These are not particularly useful. And for every DNS query, there's a whole bunch of response stuff. And if I just want to know, I want to know what DNS requests are being sent out. So I really only care about the queries. I'm not interested in the responses. I'm not worried about somebody hijacking a DNS and changing the IP address that comes back. That's more of a niche worry that's not part of my threat model, even though it is important for in some cases. So I'm just I just want to see the queries going out from my network. So what I can do is that with this, now that pfSense has the log, and it even shows the log path there. That's exactly where my DNS log is. So you can set up, because I was doing this in Splunk, you can install the Splunk forwarder onto pfSense because they have a FreeBSD version of it. And then you can tell the forwarder, take that log and send it to my Splunk server. But then Splunk is getting all this noise and signal together. I want to cut down the noise a lot. So in Splunk, you can set what's called a transform, which it's basically a simple regex that I put into it that says, throw out everything on this log file unless it has the word query. And so then you can see here, this is the Splunk view. All of these records that it's showing are only the queries. I'm not seeing any of the response data. So this cuts down a lot of the noise. And then to further cut it down, because Splunk you do searches with, you can filter your searches in the top, and you can see on the top bar there, I've said, I don't want to see in address, which is the reverse DNS stuff. I don't need that. I cut out Netgear, which is the NTP server for pfSense. I don't need to see all those messages. I'm fully aware that it's doing them regularly. And I cut out Google, although I really should have written it as Google star, because there are a couple, it just takes the word with the way that Splunk interprets it. It's like, okay, the word Google separated out. It cut all those out, but you can see like the second and third records here still are Google hosted .googleusercontent.com. And I could cut those out if I did Google star instead. But I didn't feel like making another screenshot, and this is fine. So the other thing you can do so now we've got we've got some interesting data. You can set custom fields within Splunk. And so what I did is you take a record and you say, the only thing I'm interested in is I just want to see the actual DNS record. I don't care about all the other stuff. And so I've done that here. You can, it's down the left side, and I'm going to zoom in on it here where you click on it. The DNS request is a custom defined DNS request, and it makes a regex that pulls out, it figures out the format of the log and says, okay, you're only interested in this column of it when we break it apart. And so we can see here, these are the top records, and most of these are things I expect to see, but it's kind of interesting to get insight into your network to see what's really talking out. And I can see the Adobe Updater is incredibly chatty. It is at the top by a lot. And then I can see, things I expect like Amazon stuff, Apple DNS, Google APIs. The thing at the bottom then I was like, oh, this is interesting. I don't know what that is. It says, and if you can't read it, it says rex.richrelevance.com. And I didn't think it was anything malicious. It didn't seem malicious, but you could use monitoring like this to find malicious things. But anyway, it's something I did not know what it was, so I was curious to look it up. I did a quick search on it. I find out, oh, it's a shopping experience site. So someone was doing some online shopping at the time with a site that partners with this site, and that's where all those hits were coming from. But this, doing this DNS logging, it really gives you a lot of insight into what's happening on the network. And then from that, now that we're doing all this monitoring, we can build custom alerting that could be useful depending on your threat model. So in this case, I came up with a hypothetical threat model because we're building this for our home network with kids, that I'm worried that my kid is going to be playing games when they should be doing homework or sleeping. So this is, I don't know how well you can read it all the way back there, but grayed out on the left-hand side, you can see the search in the background, and then the modal pop-up window is the alert that's built off the search. So in the search, I'm searching my DNS records that I'm logging now, and I'm just looking for a DNS request that matches Blizzard. So I'll know if my kid is playing Overwatch or Hearthstone or World of Warcraft or anything on Blizzard servers. Depending on your threat model, your kid might play different games and you might put something different in there. It could put Mojang in and find out if they're logging into Minecraft. So then from this, and you can't see it because it's blocked by the pop-up window, but there's you set a time window on your search, and this search was just for the last 12 hours. And then when you create the alert, you tell it what time I want this alert to go off. And I said, I want this alert to go off at 8 a.m. every day. So this is going to tell me, because it's a 12-hour search window, if any of these, if this server was hit between 8 p.m. and 8 a.m., I will get, it can have an email sent to me from it. The alert doesn't have to, it can be an email. You can also set other actions from it. You can have it trigger webhooks. You can have it run scripts, depending on what you need it to do. So if you were really ambitious, you could build like a family dashboard that if a child violates a policy based on an alert, then it automatically updates the dashboard and shows like check marks next to things that they've done that they shouldn't have. That's probably more work than I'm willing to do, but some people might find that really fun. It's really cool, really powerful stuff you can do with the monitoring and alerting. So now we're going to move on to the final step of DADSEC, and that is incident response. When you're monitoring and alerting on things, once you've found out something's gone wrong, then it is an incident. You need to respond to it. It may not be incident response as we often think of in InfoSec, but it still is. So there's two kinds. There's technical incident response, like if there's, and this is something that you could find with your monitoring. If you're looking at DNS and you see, a lot of hits going out to a strange Russian server, you might have malware or a Bitcoin miner that got installed in your network. And that's something you need to track down, figure out how it got there, get it off, make sure it doesn't happen again. Spillage, I'm taking from the, in the DoD parlance, it's, if you're not familiar, it's when classified information is exposed in an unclassified environment. It's called spillage. And this is any time if there's data that is exposed that shouldn't have been. So this is kind of my earlier threat model. If a child gives out their address to a stranger online, or if they accidentally, give away a password that could be important, it's something that needs to be addressed and cleaned up. But these are kind of straightforward. The technical incident response is kind of straightforward. The personnel incident response is a little squishier. And that's in a business, it would be an acceptable use policy violation where, so you find out from your monitoring and logging that, somebody is going to websites that they should not be going to on the right time. And now like I said, in a business, that's something that's going to be written out in a contract. People are going to know what the policy is, and there's going to be set consequences and HR procedures for that. Your family is not going to work like that, I assume. Some people might have written out computer policies for their children. Again, that's not something I'm interested in doing. But it is something where it's more, you have expectations. Those expectations should be understood by all parties. And if they are broken, then there needs to be discussions had. So the incident response on these kinds of things for parents is more, it's mostly going to be uncomfortable conversations. But it's important to know that these things are what's happening, what your kids are doing and seeing online, so that you can have conversations around it rather than leaving things in the dark and letting things spiral out of control. Because that can end up with things like kids start on one path and end up joining the Klan. So we don't want that to happen. So you can see with the 3 steps of DADSEC, we end up with TMI. And we have the TMI cycle of DADSEC. So it works as a cycle because we start with our threat modeling, and then the threat modeling leads to monitoring and alerting. And from the monitoring and alerting, we have incident response. And then from all of that, we go back and revise the threat model based on what we've learned from monitoring and incident response. And over time, you end up having TMI about what your children are doing on the internet. So to wrap up, excuse me, going to another business trope like I did with the iron triangle earlier, DADSEC is a lot about the 80-20 rule, wherein the idea that 20% of the time spent on a project accomplishes 80% of the project, and then the final 20% takes another 80% of the time. And this is kind of like the way that I think about implementing security in this DADSEC model, is that you really only need to put in about 20% of the effort to get enough coverage to do what you need to do. The major problem is most people aren't even putting in that 20%, they're putting in 1 or 2%. So you just need to put in a little bit of effort to get a lot of results out. And yeah, finishing up, DADSEC it's all about managing your time and resources so that you are kind of doing half-assed security. But that's all that you need to do to really get enough results at home. So, thank you. Any questions?